Hello everybody, my name is Craig Bennett, and today I'm going to get into a video on 3D printers. Now, as far as this video goes, I'm going to really get into the different types of printers, where it's FDM, SLA, DLP, and obviously a CNC, why not? But which one should you really go for so you know which line to go down? Because these things are not cheap, and you need to know what you're getting into before you go into all this stuff. Now, I'm going to be staying away from things like powder prints and also metal prints. The metal prints, you can get them that are a little bit more cheaper now, but the problem is unless you're printing just something the size of a Coke can or maybe a little bit bigger, and unless you've got some kiln or something, then it's useless. Because the fact of the matter is how metal prints work at the end of the day at this time for the ones that's affordable is they take metal powder and sand, and they obviously put metal powder wherever the print needs to be, and then you take that into a kiln, heat it up for a long time, and then you break the sand away, and there you go. Well, the fact is most people don't have a kiln, for one, and also doing that, there's limits all around to that. It's very early stages for home use, and again, most people don't have a kiln for powder unless you're going. There might be some cheaper, but I honestly cannot find any less than 20,000. So as far as the FDM, this is known as a filament-based printer. This is probably what you're going to see most common in most places. And the fact is this is the one. This is actually the one I'm getting. And the biggest thing to note with this is FDM, unlike the SLA, unlike the DLP, FDM, you tend to have a higher amount of people who's using this stuff. This stuff tends to be much easier to fix, much easier to replace parts, and so on. Now, as far as the sticker shock, note that there is some in the $200 range or whatever. But the big thing to note here is you need to basically know a few things. Is it consistent as far as the output, and also is it safe? These are the two big things. But first off, how does it work? Basically, it uses a filament, this thing that looks like weeder string, and it kind of acts like a hot glue gun, where you got a hot glue stick that goes in, it heats up in it, and hot glue comes out at the other end. Well, the same thing happens here. This bottom part is a bed, is a building bed or a builder's bed. Basically, you have layers, and as it's putting it down, when it gets done, it will, depending on the program, it might do some infill or whatever, but it will go up a layer and just start with that, and so it goes layer by layer by layer by layer. So this is a big thing to note with that, is that you can actually have it where it does infill 5%, 10%, 20%, whatever you really want, depending on the program. And what that allows you to do is make a part much lighter, whereas with SLA and DLP is they are solid unless you hollow it out in the model itself. So this is a big thing to note, is you can actually lighten up your materials, which cuts down on shipping costs and stuff if you're shipping stuff out. So, and also it cuts down on the materials itself. Now, the neat thing with this, with the filament-based systems, is there's many different types of filaments. You got PVA, which is water soluble, and I think there's a few other water soluble ones. PLA is your biggest one. PLA and ABS is your two biggest filaments that's out there. PLA is biodegradable. ABS is what they use in Legos and stuff, and tools and fewer things. The neat thing with PLA is there's some PLA with wood powder in it. There's some with metal powder in it. The neat thing with that is you can make things that look like they're brass, copper, or whatever, or wood, or whatever. So you can get that effect with it. And you can even stain it if it's wood, and sand it down and all the other stuff. So it's very straightforward and very neat. Plus, on top of that, you can print off, and some models or some attachments will allow you to print off multiple colors. So, like, say for example, if you want the eyes to be white and have the black pupil and the rest of the face be something else, you can have each thing be its own different color depending on the printer itself. So this is very important to note, that you have these type of abilities. And plus, again, with the water soluble, let's say for example you're printing something that, because keep in mind it prints by layer to by layer, and if something's way too far out, then it can cause problems either further up or whatever. So you need some type of support Well, let's say for example with the mouth, if you want to do a detailed mouth, you're probably going to need some type of support. So what's going to end up happening is the is if you use regular support material, which tends to be the whatever you're printing off with, this can cause problems where you can have chipping or some other problems that happen with there, where like with water soluble, the support is not really connected to the part. All you have to do is dunk the entire model into a tank of water. The water soluble stuff, it tends to be biodegradable, so all you have to do is dunk it in there for an hour or two, and the water soluble stuff will be gone, it will be dissolved, and you can pull your model out plus the support that's in there, throw the water out in the yard and keep moving on. So this is something very neat that you can do. But with that one in mind, you're going to need some things like isopropyl alcohol to clean the table and whatever, and maybe some wire cutters or some dikes or whatever to deal with the filament and you know, some basic stuff, whatever the company tells you. So with that one in mind, you need to keep that one in mind, but you also need to keep in mind safety. It's a major thing, because you're basically doing a hot glue gun type of thing where you got it hot in, and the bed itself can be heated in most models. Well, the thing is this gets very, very hot. We're talking about 200 Celsius, which gets, it's basically a stove in a sense. So this is not a toy by any stretch of imagination. Don't go out and buy this for an 8-year-old or something like that. This is not a toy. The thing is it's a tool through and through, and if the part falls down or something else, it can cause a fire. So what happens on most 3D print companies, they use the same motherboard, same software on a motherboard and all the other. And what happens is in some companies, they try to cut corners by turning off safety features on the motherboard, which would help you from burning down your house. Yes, a printer might be $200, but make sure it's not cutting those corners, because if they're cutting those corners, what other corners are they cutting? This is something that you want to stay away from. Now, there's $200 printers that don't cut corners at all. There's $1,000 printers that cut all corners. So you need to do research per printer. I don't care about price range. So note that. The reason why I'm going with Prusa is simply they don't cut corners, and they even add extra safety features on there. Plus on top of that, they got to see, whereas some you do one print after another and be totally different, whereas with Prusa it's fairly similar. So note these things. And then on top of that, with Prusa, the whole thing's open source. The materials and all that stuff, I can print off the materials, I can do whatever, and I can modify the software as I want. So we got abilities there. So these are big things to note. And by the way, I want to mention, if you get something like this and you want to put an enclosure, make sure you use a smoke detector. If you want to get something like this, the SLA PLD, then make sure you get some type of tray to go underneath it in case it leaks. It's just a quick tip. So as far as this goes, as the FDM prints from the bottom up, you got top-down print Premiere. So what happens is basically this head goes all the way down into what's called a resin. Now here's the thing, this is more than less weir string. Yeah, it's not exact, but still, it's you go hold it, you go mess with it, it's more than less weir string. Yeah, you might have nylon or whatever, which you would never use, but still, this is resins. Now there is two different type of resins. You got water wash, which is a little bit newer, and then you got normal resins. So normal resins is very toxic. You have to wear gloves. Supposedly, I never mess with an SLA or a DLP, but they're very toxic. Supposedly it smells pretty bad when it's doing it. And the same thing can happen here. It smells pretty bad, but you just have a well-ventilated area and be fine. Supposedly with this is a little bit worse depending on the person, and that's a person-by-person type of thing. But the big thing to note here is the worst you can get here is maybe burnt from that. You know, it's kind of like hot glue, where here you have toxins that can touch your skin or touch your eyes or whatever it may be. So this is a major thing to note, is you got to use a resin. depending on what you get, it can be very toxic. And then once you get it off here, once you get your part built and whatever, what you have to do is take the part and dunk it into a tank about this, whatever size that will hold the thing, full of isopropyl alcohol, because isopropyl alcohol is now touching the resin that's still on the thing. What the thing is that is contaminated, so that is considered more or less as a biohazard. So this means that you cannot exactly, in fact even a resin itself, you cannot throw it out in your yard, and you really shouldn't put any of this down the sink, not because, oh, environment, but because it will destroy your pipes and stuff like that, or it will destroy your septic tank. So you really can't put all that down the sink like that. So you're going to have a special area that you can drop this stuff off, especially the other. So this is a big thing to note. Whereas like this, okay, the worst that happens is I get some, you know, plastic parts that I can just throw in and dump. This, I got to take it to a very specific location to dump the parts, to dump the stuff. That's something that you got to keep in mind. If you're like myself and don't really have that access, then this might keep you from getting in the first place. Whereas this, the worst case scenario, I could just go down to a normal dump and just dump plastic. So yeah. Now, as far as that goes, the big thing to note when it comes to here is the water wash. The water wash is fairly new. There's only like 2 or 3 companies, I think, that does it. I emailed each one I could find, and I hadn't heard back from anyone. I asked, is it biodegradable, and can it kill a septic tank? I hadn't heard anything back from any of them. I also asked a bunch of other people who's on YouTube who uses this stuff, and not a single person has came back and said anything unfavorable. Basically, they all said they don't know if it's biodegradable. They don't know if you just throw it down a sink and nothing's going to happen. So even they don't really know, and they're even saying that it probably is still toxic to some degree. Even on the bottles say, do not get in your eyes, it's toxic. So, you know, you still got to deal with that stuff, where again, with this, the worst you're going to get is a burn. Now, why would you even consider this over that? Well, the thing is, and it gets down here, this is a high-end one, by the way. There's some of these that are $200, so note that. But you can get very tight dimensions on this, whereas with a FDM, what you're looking at, I forgot exactly, I think it's like 0.04 or something like that. Print, basically, you're going to get a line effect. When you're printing something like this, especially like with this particular thing where the head's going up, you're going to get a line effect, and the problem with that is you're going to have to send it out and do a whole bunch of other things. Whereas this, that's not the case at all. You're pretty much going to have to use a microscope or a magnifier to see the lines and stuff on most of these, not all of them. Some of them you still get the line effect. So note that it's a lot more engineer friendly. Plus, on top of that, it has other type of benefits. The whole thing is solid. The plastic that comes off it, unless you specifically make it hollow, and you know, overall, you can actually sell these things, the parts you make off it, for a little bit more money. The engineer firms, they like it a lot more, but still, again, this is going to be a hit or miss depending on the area and stuff like that, so keep that in mind. Biggest thing to keep in mind though is the tolerance. Now, one thing I want to mention right now before you say, all right, it's worth me dealing with the toxins and whatnot, I've asked, I never played with an SLA or DLP, but I've asked people who have played with them, if you print off, say, a 1-inch block by 1-inch block on both, what would the cost be at the end of the day? Because with the filaments, I can get filaments for like $14 or something like that. And like the water soluble, it'd be a little bit more up there, like in the $60 or whatever. But here, what people are saying is it's averaging around 7 times more than a filament, 7 times more than a filament print. So even the people who has these things, they even admit that they rarely print for themselves unless if a customer really needs it to be something like that. The fact of the matter is they tend to just print everything by filament anyways. So what most recommend people to do is go with the FDM over the SLA and the DLP. Make sure between the toxicity and the price and all the other things, it's just better to go with the FDM if all possible. Obviously you can upgrade later on, get the SLA, there's no problem with that, but you're just going to have to keep in mind all these things. Plus on top of that, there's things on the SLA and FDM that's very similar, making the 3D models and all the other, and position it and all the other things. The SLA is a little bit different in positioning and a few other things, but for the most part, you know, it's fairly similar on some of these things. It's just the FDM have a little bit more support, and the SLA will allow you to do a lot more complex things. So as far as the CNC is simply, it's a in a nutshell, this instead of these two where it adds to things. So for example, it puts something down, or this, you know, it adds to the plate. This takes away. This you put a piece of metal or piece of wood, and it will take away from it. The neat thing with the CNC machines is, unlike this, like say for example, this is the only face you're going to be printing on, and this is the only face you're going to be printing on, unless maybe way down. I doubt you're going to get this on the SLAs, but unless if you get it way down the road where the plate can move and do some weird stuff, which would be kind of cool. The thing is a CNC machine, some of them, not all of them, they can print from the top, from the bottom, from the sides, whatever. It really depends, but basically a CNC machine can allow you to do a lot more. Plus, as many know, wood is a lot cheaper than some of these other things and a lot more sturdier. Obviously, when you get into like stuff like the filament's still going to be cheaper in some cases, but if you're looking for a sturdy, the CNC is going to be where you're at. You just got to keep in mind that, you know, weights and whatever when you're dealing with this stuff. So as far as that goes, that's a big thing to note. Now, what's the problem with a CNC machine? Problem with a CNC machine is right now they are not there yet. As you see here, you can get them $200, whatever, which is not bad at all, but you got to babysit it. Whereas right now, the head breaks or whatever, there's nothing to really stop it. Whereas with these, especially when you get into the MK3, if something's stopping the head or something's off, like the filament goes out or whatever, it stops and it tries to take the best course of action, but it stops. It won't continue in case of it might wreck the print. Whereas the CNC, it doesn't know, it just keeps going. So the head might be screwed up, but or the wood might be smoking or something like that. But yeah, you can run some problems there. So I think whenever they get to the point where they can detect these things, the safety things, then CNC machines will be worthwhile. But since Walmart is making them and all the things that's going around, because people are literally taking parts from the FDM machines and they're studying them, and you can't take a part from FDM and make a CNC because the CNC has to deal with a lot more sturdier environments and all the other stuff. But basically they're pretty much the same, other than sturdiness and obviously the heads and whatnot. So big thing to note there is it's just writing on the wall. It's obvious that in the near future this is going to be on the same magnitude as the FDM machines. So, and it can even be to the point, since again this stuff is open source and whatever, you get a good company or like something like Prusa or whatever, you might see the parts on here where you can have it print, you know, multiple sides or take away multiple sides. You might see some of the features come on to something like this. I kind of doubt it, but still, someone can hope. So as far as that goes, just note that you have these options. Again, CNC, I'll say stay away for right now. Like, you can get it if you're okay with babysitting, but other than that, you know, whatever. For starting, and keep in mind, form is like several thousand hearts, like 3,000 hearts. These are professional grade. You get these in $200 and whatever for SLA. But for these, for SLA, DLP, I'll say stay away if you're new, unless you absolutely need the how tight it can make everything. And then for the FDM, that's probably going to be your best option. Just make sure the safety features are there and all that, to make sure it's putting out consistent stuff, and that the company's good, the support on it's good, the people around it is good as far as being able to get answers. Go to Reddit and whatever, test that out, and you'll find that more than not, you're probably going to find a pretty cheap, pretty good 3D printer. Again, because it's $1,000 doesn't mean that it's a lot better. So note that, you know, shop around and take a look. But the reason why I'm going after this is known to be one of the better ones out there right now. It depends on what you're going for. So as far as that goes, hopefully this helped you out and understand this, and hopefully this can help you out in buying the right one, or at least knowing which path to go down. And I'll see you in the next video. And feel free to leave any questions down below. Hope you have a great day.